Mr. Gregory, Sister Rosa would like to know, how do astronauts train for their space flights?
Well, we try to give them the best training possible, and this involves training throughout their whole space flight, preparation for their whole space mission. Naturally, the first thing that you provide for them is a simulator, and this would be a very high-fidelity simulator so that they can actually practice, so to speak, their total mission in that vehicle. Now, there are many other things that fall into this category of training and preparation for their space flight. Number one, they have to obtain briefings from experts. For example, if they're doing any experiments, from the experiment expert, the principal investigator as we refer to him, as to exactly what they're trying to find, how to interpret the data, and how to come back with the best results. For example, picking up lunar rocks, how to document the samples you pick up from the lunar surface. Next, you have getting prepared for your spacecraft and your space mission. You want to make sure that your space suit is going to be comfortably fitted because you're going to be in it for a long period of time. And so they have quite a bit of training along that line. They actually participate in a lot of the spacecraft checkout and testing, which gives them a familiarization with their home in space for a while. They have other modes of training, such as working through the total timeline, so to speak, or exactly what they're going to be doing, practicing their script, so that when they go out on the lunar surface, they will have it down pat to exactly what they're going to be doing at what particular time. And that applies throughout the whole mission, whether they are going through their launch phase into Earth orbit to go translunar injection into lunar orbit all the way back home. So there are many facets that they have to prepare, and they are quite busy. We normally try to get them started somewhere about 9 months before their mission. Naturally, they are in training. They receive certain training before that, but they go in an intensified training about 9 months before their mission, and they eventually end up spending somewhere to approximately 50, 60, and close to the mission 70 to 80 hours a week in training. So it's quite intensive.
Another question, did earlier astronauts get more tired than Apollo crewmen do today?
Well, Sister Rosa, that's a difficult question to answer. We have no indication of it. Of course, the earlier astronauts and earlier missions were shorter. The Apollo mission, for example, was the most difficult mission we've flown to date, but we have not seen any real degradation in their ability to work in space and function in space.
Mm-hmm. And are astronauts more hungry and thirsty when they're in space than on the ground?
Actually, no. They are many times in a period of inactivity, such as when you're going from the Earth up to the moon. You are in your spacecraft, you're taking navigational checks, and you're keeping the spacecraft functioning correctly, but you're not as busy and you're not moving around like we would be on Earth here. But their calorie intake is about the same as the normal on the ground here.
And one final question from our listener. Do they eat only pills?
No, we actually have prepared food for them, and they get to choose their own menu, but it's a freeze-dried type of food that is reconstituted with water and permits them to have a fairly decent meal. Now, they have a variety all the way from strawberry shortcake to lobster to turkey dinner to anything they want.
And with larger spacecraft, as in Apollo, there's more room for pre-prepared foods.
Yes, we anticipate to have an oven and a freezer and a refrigerator in future missions.
Paul, what is unique about this small color camera used on Apollo 12?
Well, actually, this camera is very much like a commercial black and white camera. The difference is that there is a color wheel rotating in front of the optical input to the camera. And this color wheel contains a red filter, a green filter, and a blue filter.
The basic colors?
That's correct, the basic colors. And as the filter wheel rotates in front of the lens opening, well, these different colors are transmitted back into the camera. The output of the camera actually looks very much like a standard black and white camera, except that every field that you get is a different color.
Mm-hmm. Now, actually, this camera on the surface of the moon or in the command module has a little motor in there with a wheel mechanically rotating. This was designed to simplify the mechanics, the electronics, and the weight to be used on the spacecraft and let you do all the complicated stuff back here on Earth where weight was no problem, wasn't it?
Yes, that is correct. Normally a studio camera has 3 guns in it. It's a rather large camera because of the requirement for three camera tubes, I should say. And this camera only requires 1 camera tube. We then convert back here down on the ground. We convert this signal from the camera, having only 1 gun, to an output of a camera that looks, a camera that has 3 guns. In other words, we convert the signal from a 1-gun camera to an output that looks like it comes from a camera with 3 guns.
How long have you and other engineers and the engineers at the Westinghouse Corporation, which built it, been working on this and developing it?
Oh, let's see. We have actually been exploring different ideas like this for a long time now. We here at NASA have been working on it for about probably the last 5 or 6 years, off and on. However, it was not decided until about 6 or 8 months ago that we would attempt to use this particular technique for televising color back from outer space.
And then we saw its first use on Apollo 10 when Tom Stafford, John Young, and Gene Cernan took it with them, didn't we?
That's correct. That's the first time it was used in outer space.
And I understand that one of the very same cameras used on that mission and in Apollo 11 are on board.
That's correct. The camera that was used on Apollo 10 is the one that we are now modifying for use on the lunar surface. It will be in the lunar module on Apollo 12. The camera that we flew in the command module on Apollo 11 will fly again in the command module on Apollo 12.
And we're going to lose one of them this time, aren't we?
And we won't be able to bring back the one we use on the lunar surface.
You had to modify that expensive color camera a bit in order to adapt it to the lunar environment too, didn't you?
Yes, we had to do several things to it. Probably the most important thing we did was to lower the power consumption of the camera so that we could withstand the thermal vacuum environment which we find on the lunar surface. We lowered this power requirement, the power consumption, primarily by reducing the wattage of the motor which drives the color wheel.